Hey everyone. So today we're going to start looking at polar coordinates, which is basically a different way that we can plot points. So currently our coordinate system that we've been looking at so far is our Cartesian coordinate system, which is our X and Y coordinate system. In this video, we're going to look at polar coordinates, which instead of using X and Y to plot points, uses R and theta. So it's based off of an angle and a radius. So here's kind of what we're looking at. So let's say we have our x-axis, or our polar axis, as it's going to be referred to here, coming from some point, which would be our origin point. Then in order to plot a point in polar coordinates, basically it's based off of some angle theta. So we measure our theta just like usual from that x-axis up to some point P. Okay, so that would be like the terminal side of our angle. And our radius is just the distance from the origin up to that point P. Okay, so this point right here would be plotted as R and theta. Okay, so when we're looking at polar coordinates, a lot of times we'll use this polar grid paper, and it looks like a spider web. So we have in here still our X and Y axis like usual, but then we also have these circles, and every circle represents a different radius. And then just think about your regular unit circle with your angles. And I've gone ahead and I found some polar coordinate paper that has all of the 30 and 60-degree angles on it. So basically, if you think about this like normal, this would be our 0, maybe pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, pi, 7 pi over 6, 4 pi over 3, 3 pi over 2, 5 pi over 3, and 11 pi over 6. So all of our 30 and 60-degree angles. And of course, if you wanted to sort of add your 45s in there, you can just sort of think about that midpoint in between. So that would be our 45s. So our pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay. All right, so let's go ahead and let's take a look at a couple of these points, and let's try to plot them over here. So our first one, okay, is the point 1, 3 pi over 4. So our radius is 1, which means we're going to be on the first circle, and our angle is 3 pi over 4. So that's our 45-degree angle in quadrant 2. So if we're looking at our 3 pi over 4 line right here, okay, let me just make that a little bit less thick. It's easier to plot on. Let me do the same thing with this one. Okay. All right, so we're looking at our 3 pi over 4 angle, radius of 1, so going out to the first circle. And we're just going to plot our point right there. So R and theta, R is 1, so we're on the first circle. Theta is 3 pi over 4, so we're on the 3 pi over 4 line, and we plot our point. Okay, so that's really all there is to these polar coordinates. So identify what circle you're on, look at your angle, plot your point. Okay, so our next one is 3 negative pi over 6. So radius of 3 means we are on the third circle on this one. And then we have an angle of negative pi over 6. So just like usual, negative angles rotate around in the clockwise direction. So negative pi over 6 would be on our 11 pi over 6 line. And we're just going out to the third circle. 1, 2, 3. And we've got our point right there. So 3 negative pi over 6. Okay. And then let's look at part C here. So 3 and 3 pi. Okay, so Again, radius is 3, so we're on the third circle. Angle is 3 pi on this one. So with 3 pi, of course, we're more than a full rotation around our circle. So we would have 1 pi, 2 pi, 3 pi would be back over here on this pi line. And on our third radius, 1, 2, 3 out, and that would be our point right there. All right, so the last one is a little bit different because we have a negative radius on this one. So let's start by looking at our angle, which is pi over 4. Okay, so this is our pi over 4 line right over here in quadrant 1. Okay, now the radius of negative 4, I think we're thinking we're on that third circle, but essentially what a negative radius value does is it reflects us across the origin. So think if this were pi over 4 with a radius of positive 4, we would have our point plotted right here on the pi over 4 line, 4 circles out. But what the negative radius does is it takes that and it flips it across the origin, which puts us instead down here in quadrant 3, right? So negative radius means we start on the pi over 4 line, but then we're reflected over across the unit circle, across the origin into quadrant 3. Okay, so let's just go ahead and plot that point then. 1, 2, 3, 4 circles out, and we're down here in quadrant 3. Okay. All right, now this one's not on here, but let's just say, for example, let me just show you another one with that negative radius. Let's say we had, I don't know, negative 2 pi over 3. Okay, just to show you another example here. All right, so we would start by looking for our 2 pi over 3 line. So here's our 2 pi over 3, okay? And then the negative radius means it's going to flip us across the unit circle. So that would take us down into quadrant 4, out to the second circle. And we would just plot our point right there. Okay, so again, when we have a negative radius, start by looking for your angle on the unit circle, and then reflect it across the circle into the opposite quadrant across the origin, and plot your point. Okay. All right, guys, so this is the basic idea with polar coordinates. So they're all based on a radius and an angle. Okay. All right, now, as you can sort of expect here, polar coordinates, unlike our regular Cartesian x and y coordinates, are not unique. Okay, and what I mean by that is, say, take, for example, part B. We had our point 3 and negative pi over 6. But we know that the angle negative pi over 6 is the same as 11 pi over 6. So we could also write this as the point 3, 11 pi over 6. Or if we look back at C right here, we had the point 3 and 3 pi. But 3 pi is in the same location as 1 pi. So this would be the same as 3 and pi. So our polar coordinates, there are an infinite number of ways that we could actually write every point, depending on whether you have a positive radius and a positive angle, or maybe you have a negative angle, maybe you have a negative radius, maybe you have an angle that is bigger than 2 pi, or you have an angle that's less than negative 2 pi. There's a lot of different ways that you can write these points in polar coordinates. So the next thing we're going to do is we're going to take a look at a point. We have our point 2 and pi over 3, and we're going to think of a few different ways that we can write this same point, but using different polar coordinates. So the first thing I want to do is just plot our point. Okay, so we have the point 2 and pi over 3. So pi over 3 will be over here in quadrant 1, and then radius of 2 just means we're going out 2 circles. And we have our point right there. Okay. All right, so we are trying to think of, we're going to find four different ways that we can write this exact same point using either a different radius or a different angle. Okay, so what I want to do is I want to find two other ways to write our polar coordinates with a positive radius, and I want to find two other ways to write our polar coordinates with a negative radius. So let's go ahead and let's start with the positive radius. Okay. So we're always trying to make sure we get back to this exact same point. So if we're looking for different ways to write this point with a positive radius, that means we're going to have a radius of 2, no matter what, that can't change. And we're basically just thinking of different angles that are coterminal with pi over 3. So one way that we could get a coterminal angle would be to just make an extra rotation around our unit circle. So if we went all the way around plus that pi over 3. This would be a coterminal angle. It would get us back to the exact same point, but it would be a different way of representing it. So if we think about our pi over 3 plus a complete rotation around our circle, that would give us an angle of 7 pi over 3. So this would be another way that we could represent this point. It would be 2 and 7 pi over 3. Okay, well, another way that we could get to that same point, if we're just thinking of trying to get a coterminal angle, would be to rotate around in the opposite direction. So if we could think of it as a negative angle instead. Okay, so if we think about rotating around backwards, that same coterminal angle written as a negative would be negative 5 pi over 3. So these would be two possible different notations for this polar coordinate, just using different coterminal angles. All right, so the other thing we want to think about then is how could we write this point with a negative radius? Okay. All right, so again, we're always trying to get back to the same point. Now remember what I said earlier, and that is that whenever you're dealing with a negative radius, what it basically does is it reflects it across the unit circle. It reflects it across the origin. So what that means for us is that we're going to try and find angles that fall on this line down here in quadrant 3, which then the negative radius will reflect us back up to quadrant 1. So we want to make sure that we have a radius of negative 2, all right, so that when we're reflected across the origin, we get back to this point up here in quadrant 1, right? So just like before, there's a couple different ways that we can find this angle. We could either use a positive angle or we could use a negative angle. Let's go ahead and first think about our negative angle. So if we were to rotate around clockwise to get to this angle in quadrant 3, all right, now keep in mind that we originally had our angle of 2 pi over 3, so we're trying to get to that same reference angle or I'm sorry, our angle was 1 pi over 3, excuse me. So our angle was 1 pi over 3 in quadrant 1, and we're trying to get down here using that same reference angle in quadrant 3. So it still has to be a 60-degree angle, in other words. So if we were to go the negative direction, that would be a negative 2 pi over 3 to get to that angle in quadrant 3. And then if we wanted to go in the positive direction to get around to here to quadrant 3, so our 60-degree reference angle in quadrant 3 would be an angle of 4 pi over 3. Okay, so again, we're using the quadrant 3 angle because when you have a negative radius, it flips it across the origin and brings us back up to that point that we want in quadrant 1. Okay. All right, now there are other ways to write the same point. We could keep going around our unit circle again. You could add another 2 pi or you could subtract another 2 pi, but these are a few examples of different ways that we can write these polar coordinates. All right, I think I'm actually going to end this video here, and in the next video, we're going to take a look at converting back and forth between polar and rectangular.